Welcome all. In this lecture, we are going to deal with another example, that is example number 13. Determine the stability of a closed loop control system whose characteristic equation is given in the question, that is s to the power 5 plus s to the power 4 plus 2s cube plus 2s square plus 11s plus 10. So this is the characteristic equation, and we need to check that the system given to us is stable or not based on its characteristic equation by the help of Routh criteria. So firstly, we have to form a Routh array, then we will check that the system is stable or not. So firstly, we will find out the odd power of s, that is s to the power 5, s to the power 3, s to the power 1. So the coefficient of odd power of s are 1, then 2, then 11, and the coefficient of even power of s are 1, then 2, then 10. Now let's form a Routh array. So here the highest power of s is s to the power 5, then s to the power 4, then s to the power 3, then s to the power 2, s to the power 1, s to the power 0. Since the highest power of s is s to the power 5 and 5 is an odd number, so we will write the odd coefficients first. So 1, then 2, then 11. 4 is an even number, so we will write here the even coefficients: 1, then 2, then 10. Later on, we will fill all the elements of a Routh array by the cross multiplication method. So this 1 will be multiplied with 2, minus 2 will be multiplied with 1. The whole thing will be divided by this 1. So we will get 0 here. After this 1 will be multiplied with 11, minus 10 multiplied with 1. The whole thing will be divided with 1. So we will get 1 as the output. 0, 1. No other column is remaining for the further multiplication, so we will write simply 0 here. We notice that 0 appears as the first element of this row. So this is type 2 variety of question. So what we do in the type 2 variety of question, we simply just replace s in the characteristic equation with 1 by z. So replace s in characteristic equation with 1 over z. We get 1 over z to the power 5 plus 1 over z to the power 4 plus 2 1 over z to the power 3 plus 2 1 over z to the power 2 plus 11 1 over z plus 10 is equals to 0. Further on taking the LCM, the final equation we will get is 10 z to the power 5 plus 11 z to the power 4 plus 2 z to the power 3 plus 2 z to the power 2 plus z plus 1 is equals to 0. So this is the final characteristic equation on the basis of which we will again form a Routh array and check whether our system is stable or not. So this is the characteristic equation. Then we will find out the odd power of z, that is z to the power 5, z to the power 3, z to the power 1. So coefficient of odd power of s is 10, then 2, then 1. Coefficient of even power of s z is 11, then 2, then 1. So we will again form a Routh array. So highest power of z is z to the power 5, z to the power 5, z to the power 4, z to the power 3, z to the power 2, z to the power 1, and z to the power 0 finally. Since 5 is an odd number, so we will write the odd coefficients first. So odd coefficients are 10, 2 and 1. So we write 10, 2 and 1. After that 4 is an even number, so we will write even coefficients first, that is 11, 2 and 1. After that we will perform the cross multiplication method to fill all the entries that are remaining in the Routh array. So here 11 multiplied with 2 minus 2 multiplied with 10, the whole equation divided by 11, we get 2 over 11 is output. Moving on to further step, 11 multiplied with 1 minus 1 multiplied with 10, whole thing divided by 11, we will get 1 over 11 as output. No other column for further multiplication, so we will simply write 0 here. After this 2 by 11 multiplied with 2 minus 1 by 11 multiplied with 11. The whole equation will be divided by 2 by 11. So we will get minus 7 by 2 as output. So minus 7 by 2 as output. After this 2 by 11 multiplied with 1 minus 0 multiplied with 11, so result will be 0. After this whole equation will be divided by 2 by 11, so we will get 1 only and remaining is 0. After this minus 7 by 2 multiplied with 1 by 11 minus 1 multiplied with 2 by 11, whole equation will be divided by minus 7 by 2, so we will get 1 by 7 as output. After this minus 7 by 2 multiplied with 0 minus 0 multiplied with 2 by 11, so we will get 0 as output. Entire thing will be 0. After this 1 by 7 multiplied with 1 minus 0 multiplied with minus 7 by 2, that is 0. After this whole thing will be divided by 1 by 7, so we will get 1 only. After this 1 by 7 will be multiplied with 0, minus 0 multiplied with minus 7 by 2, that is 0 only. So 0 only, and 0 here also. So our Routh array is formed successfully, and now we have to check that our system is stable or not. For checking the stability, we will simply count that how many sign changes are there. Focusing on the first column of a Routh array, we will check that 10 is positive, 11 is positive, so no sign change. 11 is positive, 2 by 11 is positive, so no sign change is there. 2 by 11 is positive, minus 7 by 2 is negative, so here one sign change is there. Minus 7 by 2 is negative and 1 by 7 is positive, so one sign change is there. 1 by 7 is positive, 1 is positive, so no sign change is there. So here total number of sign changes is equals to 2. So we can say that 2 roots lies in RHS of S-plane. So since 2 roots lies in RHS of S-plane, so we can simply say that our system is unstable. Thank you. If you like my video, then please press the like button and subscribe to my YouTube channel.